Welcome to our Smart Factory simulation. This model demonstrates how Industry 4.0 technologies improve manufacturing operations through real-time monitoring, predictive maintenance, and automated decision-making. The system consists of sensors and machines, an edge gateway, a connectivity layer, a data platform, MES or ERP integration, a historian data lake, a digital twin, dashboards, and a closed-loop control system. In this simulation, data is represented by colored pockets or dots moving through the factory network. Three types of data packets will be shown. A green dot represents normal operational data generated during regular machine operation. A yellow dot represents predictive maintenance data, such as unusual vibration patterns that may indicate future equipment wear. A red dot represents critical failure data, such as overheating conditions that require immediate action. As each pocket moves through the system, the smart factory automatically analyzes the information and determines the appropriate response. Let us first observe a green dot being generated by the sensors and machine. This packet contains normal operating information such as machine status, temperature, production counts, and performance data. The packet is sent to the edge gateway where the raw machine data is collected and standardized. It then travels through the connectivity layer, which acts as the communication bridge between factory equipment and digital systems. Once the packet reaches the data platform, the information is processed and distributed to different parts of the smart factory. The data is displayed on the dashboards and user interface, allowing operators and managers to monitor factory performance in real time. At the same time, the information is stored in the historian data lake for long-term analysis and record keeping. The digital twin also receives the data, keeping the virtual factory synchronized with actual factory operations. Since this packet represents normal operation, no alerts or corrective actions are required. Next, we are going to observe the yellow dot. This packet represents predictive maintenance data. In this example, the machine sensors detect abnormal vibration levels that are higher than normal operating conditions. When the packet is detected, the simulation briefly pauses to inspect its internal data profile. The system identifies the packet as a warning condition rather than a critical failure. The packet then follows the normal communication path through the edge gateway and connectivity layer before reaching the data platform. Once analyzed, the data platform determines the maintenance attention is required. The information is forwarded to the MES or ERP integration system where a maintenance work order can be generated automatically. The warning is also displayed on the monitoring dashboard and stored in the historian data lake for future trend analysis. No shutdown action is taken because production can continue safely. However, maintenance personnel are notified so they can inspect the equipment before a failure occurs. Finally, let us observe a red dot. This packet represents a critical machine condition. In this scenario, the sensors detect excessive overheating inside a production machine. As soon as the packet is generated, the simulation pauses to inspect its internal profile. The system immediately classifies the event as critical. When the packet reaches the data platform, a conditional decision is executed. If the packet severity is critical, the data platform instantly alerts the MES or ERP system. This ensures that supervisors and production planners are notified immediately. The event is also recorded in the historian data lake and reflected in the digital twin for future analysis. However, the most important action occurs when the packet reaches the closed-loop controller. Because the packet is classified as critical, the controller bypasses all non-essential processes. It immediately generates an emergency shutdown command and sends it directly back to the sensors and machines. This automatic response helps prevent equipment damage, product defects, and safety risks. Within milliseconds, the smart factory detects the problem, communicates the alert, and executes a corrective action without waiting for human intervention. This This Smart Factory simulation demonstrates how Industry 4.0 technologies transform traditional manufacturing into a data-driven, connected, and responsive production system. By combining IoT monitoring, predictive maintenance, digital twin technology, MES and ERP integration, and closed-loop control, manufacturers can improve efficiency, reduce downtime, and strengthen their competitiveness in the future of manufacturing. Thank you for watching.